which it receives from instruction register. Timing and control unit. This unit receives the decoded signal from instruction decoder and generates various control signals to execute the instruction. Timing and control unit provides status signals, control signals and timing signals which are necessary for any operation of memory and input-output device. It is not only generate these signals but also perform sequencing and synchronizing operations. Timing and control unit controls the whole operation of microprocessor and input-output device. It is like the brain of microprocessor. Interrupt control. Interrupt is a request from input-output device. On getting interrupt, CPU completes the present instruction and then attend the interrupt request. 8085 has 5 hardware interrupts, that is interrupt request, RST 7.5, RST 6.5, RST 5.5 and then trap. If 2 or more than 2 interrupts come simultaneously, CPU will execute in terms of priority. Trap has the highest priority, after that RST 7.5, RST 6.5, 5.5 and then interrupt request. Serial input-output control. This unit controls the transfer of serial input or output data. The SID input is used where the data serially enters, 8085, and SOD output is used where serial data leaves the 8085. The RIM, that is read interrupt mask, and SIM, that is set interrupt mask instruction are used in 8085 for serial data transfer. RIM and SIM instructions are used with serial data transfer. Here we have the pin diagram of 8085 microprocessor. 8085 microprocessor pin diagram is divided into various groups. These groups are serial input-output ports, then we have clock signals, high order address bus, multiplexed address oblique data bus, then status signals, control signals, then DMA request signals and interrupt signals. Now we will explain by one these all pins. First of all, X1 first pin and second pin, X1, X2. These are the terminals connected to an external crystal, LC or RC oscillator. These pins are used to drive internal clock generator which produces suitable clock for the operation of microprocessor. Generally, a crystal oscillator of 6 MHz is attached to these two pins, that is X1 and X2. But the operating frequency is 3 MHz because this is internally divided by 2. Then we have reset out. Reset out is an active high output signal. Reset out is active high output signal. It indicates that CPU is being reset. This signal is used by the CPU to reset other devices connected to it. After that, we have serial input data, that is SOD and SID. Serial input data is an active high serial input port pin used to accept serial 1 bit data. On the execution of RIM instructions, this data is loaded in the 7th bit of the accumulator. After that, we have SOD. Serial output data is an active high serial output port pin. Through this pin, 1 bit data is serially outputted. SOD pin is set or reset depending upon the accumulators D6 and D7 bit after the execution of SIM instruction. Then we have interrupt signals, that is trap, RST 7.5, 6.5, 5.5, interrupt request and interrupt acknowledge. These 5 pins, that is output pins, are the 5 hardware interrupts. Trap has the highest priority. RST 7.5 is lower than that, then 6.5, then 5.5. After that, interrupt request has the lowest priority. Interrupt acknowledge is the output signal. When an interrupt request is accepted by microprocessor, the microprocessor sends interrupt acknowledge signal, that is INT, it is active low. Then we have AD0 to AD7, that is low order address bus, that is multiplexed with data bus. It is bidirectional. All the pins here are bidirectional because they carry data. Data goes from microprocessor to the peripheral devices and from peripheral devices to the microprocessor. Then we have 20th number pin is VSS. Here we connect the ground of the power supply. Then we have after that high order address bus, that is A8 to A15. It is unidirectional. It is not time shared. Then we have two status signals, S0 and S1. Then we have ALE, address latch enable. Address latch enable is output pin. With the help of this pin, we can demultiplex low order address bus and data bus. When low order address oblique data bus carries the address, then ALE is high. After that, ALE becomes low, indicates that low order address bus oblique data bus carries data. Then we have read and write. These are the active low signals. Then we have input, output oblique memory. This pin is when this pin is high, then input output operation is performed. When this is low, then memory related operations are performed. Then we have ready pin. Ready is an active high input control signal. With the help of this signal, microprocessor checks the readiness of peripheral devices for data transfer, whether the peripheral device is ready to receive or send data. Then we have write and read. These are both active low signals. After that, we have reset in. Reset in is an active low input signal. It sets the program counter. When it is low, then it sets the program counter to 0. Then we have clock out. This is for providing the clock to the other peripheral devices. Hold and hold acknowledge. These are the two pins. These are used with direct memory access, DMA controller. When signal is given to hold pin is made high, then 8085 leaves the control of its buses and send a hold acknowledge signal to the DMA controller. That DMA controller can use the buses of 8085 to transfer directly data. Then VCC, Here positive 5 volt VCC is power supply is connected. This is the pin diagram indicating which pin is input pin, SID is input, this is output, then these interrupt signals are input pins. After that, hold acknowledge is output pin, and then interrupt acknowledge is output pin. This is the ALE is output, S1, S0, these are the status signals. Then we have input output oblique memory and read write signals. These are also output signals. These pins on the chip can be grouped into 6 groups: address bus, data bus, control and status signals, power supply and frequency, then externally initiated signals, serial input output ports. The 8085 microprocessor can almost qualify as an microprocessing unit, but it has the following two limitations. The low order address bus of 8085 microprocessor is multiplexed, time shared with the data bus. The buses need to be demultiplexed. Then appropriate control signals needed to be generated to interface memory and input output with the 8085. Demultiplexing low order address bus and data bus. The AD0 to AD7 lines are serving as dual purpose, and that they need to be demultiplexed to get all information. The high order bits of the address remain on the bus for 3 clock periods. However, the low order bits remain for only 1 clock period, and they would be lost if they are not saved externally. Also notice that the low order bits of the address disappear when they are needed most. Demultiplexing AD0 to AD7. To make sure we have the entire address for the full 3 clock cycles, we will use an external latch to save the value of AD0 to AD7 when it is carrying the address bits. We use the address latch enable signal to enable this latch. Here it is shown ALE signal is used to separate to demultiplex low order address and data bus. Given that the ALE operates as a pulse during T1, we will be able to latch the address. Then the ALE goes low, the address is saved, and AD7 to AD0 lines can be used for their purpose as bidirectional data bus. Generating control signals. The 8085 generates a single read signal. However, the signal needs to be used with both memory and input output. So it must be combined with the input output oblique memory signal to generate different control signals for memory and input output. Here from these 3 signals we generate separate 4 signals, that is memory read, memory write, input output read, input output write. How a stored program is executed. The starting memory address is transferred into the program counter. Now microprocessor executes the program as given below. It is divided in 2 parts. One is fetch operation, other is execution operation. In fetch operation, microprocessor will transfer 16-bit address from program counter to address lines. So desired memory location is selected. The microprocessor then gives reading location, that is read signal low. So 8-bit instruction code is transferred from selected memory location to data pins. This instruction code is transferred by microprocessor from data bus to instruction register. Then execution operation. In this, the instruction code is transferred from IR, instruction register, to the instruction decoder. The instruction decoding unit decodes the instructions and provides information to timing and control unit to take further actions. If the instruction code is of 2 or 3 bytes, then the circuit will read second and third byte of the instruction from memory and then execute the corresponding instruction. Cycles and states. Here T state, one subdivision of an operation, that is a T state lasts for one clock period. An instruction's execution length is usually measured in T states, that is clock cycles. Then we have machine cycle. The time required to complete one operation of accessing memory input output or acknowledging an external request. This cycle may consist of 3 to 6 T states. Instruction cycle, the time required to complete the execution of an instruction. In the 8085, an instruction cycle may consist of 1 to 6 machine cycles. Some important questions. Why the address bus is unidirectional in 8085? The address bus is unidirectional because address information is always given by the microprocessor to input output devices and memory. What is the Intel 8085 used for? It is used for computing. Why were the 8085 microprocessor given that name? In 8085, 5 means the microprocessor operates at positive 5 volt. Third 8 means 8 bits is word length is 1 byte. It is a name to identify chip. Multiplexing. Why multiplexing is required? Multiplexing of data and address buses is done to reduce the pin count of the microprocessor chip. Which stack is used in 8085? Last in, first out. Stack is used in 8085. In this type of stack, the last stored information can be retrieved first. What are the hardware interrupts? Trap, RST 7.5, 6.5, 5.5 and interrupt request. What are the software interrupts? Software interrupts are RST 0 to RST 7. What is meant by a bus? A bus is a group of conducting lines that carries data, address and control signals. What is the purpose of registers? These are used for storage. What is the restart? RST for trap. RST for trap is 4.5. What is block diagram of 8085 microprocessor? The block of 8085 shows the signals flow of 8085 architecture. It is a way to know where you have specific memory input output etc. Thanks.